Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. We are going to answer today Unit 1 Edexcel Physics January 2022 2022 2020 إن شاء الله يا رب 2022 كل عام وانتم بخير. Okay. Let's skip the multiple choice question to the end, inshallah. As I told you several times, every time we are going to answer an experimental question like this one. Here, what do we have here in this question? A student carries out an experiment to measure the acceleration of free fall G. A ball bearing was released from the point A, okay, position A. At the time the ball bearing is to fall a distance of L from the bottom of the ball to the timer tap. Okay, this was repeated with several distances of L. Explain how the measurements obtained can be used to determine the value of G in meters per second. Your answer should include the sketch of the axes, okay, that the student would expect to obtain. شو رأيك يا شباب؟ شو الفورمولا وشو الأكسيز لازم نحطها هون وشو لازم نعمل؟ هلا because I drop it, that means the initial speed it will be starting from where? From zero. حمزة بعت لنا الجواب للإكويشن اللي لازم نستخدمها. Yes, who can give us the equation that we have to use it? Okay, don't look to the mark scheme. Correct variables refer to the time and the distance. They have to be in correct unit, and it's supposed to be a straight line, and we have to use what? Yes. Okay. في حد تاني؟ طيب. The equation that I'm going to use it is S equal UT plus half AT squared. That means the initial speed is 0. شكرا يا نور. So L equal A over 2T squared. So I can put here on the y-axis L in meters, and here on the time axis time square per second what square in time second square, and it will be a straight line starting from the origin. Okay, draw it with a with a ruler, and we know that y equal mx plus c, so that means the gradient equal g divided by 2. So from this, gravity acceleration equal what? Twice the gradient. 2 times what? The gradient. Okay. Tamam. Any question here? 5 easy marks. Write down the answer. I'll take a screenshot. Next question. Question 12. شوي بس أكبر الخط. تمام. Stokes law can be used to determine the magnitude of the viscous drag force for small spherical what object moving through what fluids. State one other condition that must be in order to make Stokes law be applied. Yes, شكرا يا نور. شكرا يا أمير. Exactly. Now Hamza give us both answers, both accepted answers. It's supposed to be laminar flow around the sphere, or you can say that the sphere must have what? A low terminal velocity. Okay, slow terminal velocity for the sphere. Okay. طيب, that's it. نيجي على ايش؟ على that's part A. Part B, what they ask. A sphere falls through the water at constant speed of 0.5 meters per second. أنا شوي مرهق وتعبان فسامحوني. Axes whether the Stokes law can be applied to the falling sphere. Okay, you should include the calculations of your answer. The diameter, that means we can find the radius. the mass of the steel to find the weight, and the upthrust is given, and the viscosity that we have to know if the viscosity of the calculation is correct or not, or if the terminal velocity by these formulas it's the same as this one or not. So we have two ways to answer this question. We can find out how much is the force, okay, the viscous drag force, and we can see how much is the velocity by it. If the velocity it's equal to the same velocity, the 0.5, that means our answer is correct. Okay, so what do we have here? Since it's falling down, that means that the weight is acting downwards, and both what and what act upwards, exactly the upthrust plus the drag force. So what we are going to say that the weight equals the upthrust plus drag. So the weight, which is mg, and the upthrust is given, we will use the same value, plus the drag, which is 6 pi r eta v. Our target is to find v. Our target is to find v and compare it with this v, with this velocity. Okay, are they equal or they are not equal? So let's continue putting the values. So here, what do we have? The mass, which is 9.8 times, 9.1 times 10 to the power of -4 multiplied by 9.81 equal the upthrust, which is 1.1 times 10 to the power of -3 plus 6 pi, the radius, which is 3 times 10 to the power of -3, half the 6, which is 3, okay, multiplied by eta, which is 9.8 times 10 to the power of -4 multiplied by v, and by using the calculator, v equal, how much is the answer? Give me the calculation, how much is the velocity by using these values? This minus this divided by this. Yes, 9.1 times 10 to the power of -4 times 9.81. Give me the answer لو سمحتوا. Minus 1.1 times 10 to the power of -3 all over 6 pi 3 times 10 to the power of -3 multiplied by 8.9 times 10 to the power of -4. Yes, what's the answer? The answer, it will be by using calculator. شباب, how much is the answer? فيش حد معاه آلة حاسبة؟ Yes, 155.5 meters per second, which is much greater than what? Than 0.5, which is much greater than 0.5. So yes, it's not accepted. Okay, assist. Okay, no, it is not. No, it is not applied or not assist. Cannot be used. تمام. خلينا نشوف next part. في ناس عم تبعتوا لي على الواتساب، لو سمحتوا حاولوا ما تبعتوا لي، الله يرضى عليكم. اوكي نكمل هلا. next part. Can you solve the equation? Okay, عبد الفتاح send ايش on the group. Can you solve the question? عبد الفتاح send on the group. Okay, I will إن شاء الله, no problem. طيب نيجي على السؤال اللي بعده. شو بحكي لنا question here 13. Question 13 talks about moment and pivot. What they said. A book of length L and weight W is positions on the shelf, okay, as shown. State what is meant by center of gravity or center of mass. Send me the answer. أيوة. It is the region where أيوة شكرا يا حمزة. Another answer. شكرا يا محمد. Another answer. Yes, correct. مش the region, the point. Okay, the point where the weight acts on, where the weight concentrate or acts at. تمام. شكرا يا نور. برافو عليك. اوكي. نكمل هلا. Now we know that the center of mass is exactly in the middle, okay, because it's uniform shape. We assume it's uniform shape. تمام. There are contact forces at the two positions where the book touch the shelf. Okay, at this point here and at this point here. Okay, the book is moved a distance x to the right, okay, of the shelf. As you can see, this is the distance x. Whenever we go to the right, the distance x, it will be greater whenever we move it to the right. The magnitude of the contact force varies with the distance x. Sketch on the graph okay, below the variation of Rx between 0 and L over 2 divided by the whole length, okay, divided by 2, half the length. You should what mark the maximum values, okay, here. هلا يا شباب احنا بنعرف انه لما تكون x 0 بيكون النورمال كونتاكت where at the edge here exactly. هلا هون معناته بيكون normal contact here and another normal contact here equal and balance what? The weight of what? Of the book. So half here, half here. So that means the value, it will be exactly W divided by 2, half the weight. Now, as we move to the right, okay, the value will increase until what? Until it reaches the maximum value, which is what? Which is W, twice the distance here. W. Why? In this situation, when it's half length, the book will be positions at this position here, okay, and that means the weight and the normal, it will be exactly on the same point above each other. Their line of action will be the same, so they have to be what? Equal. Okay, I'll not start from 0 point, no, and it doesn't start from 0 point, no. Okay, when it's 0, there is no distance of x. Both normal contact, let me redraw it for you. When it's at 0, the book is here at this point here. Okay, that means the normal contact here and the normal contact here will be equal what? The weight exactly in the middle. Okay, so that means R plus R equal W. So that means each R, it's half the W in this situation. Any question here? Okay, let's move on. Explain why the book is not remained on the shelf after x equal half. Can I repeat what, ya Hamza? You give me the answer. So again, when the book exactly at the distance x is 0, the book is in this position here as shown. The weight, it will be exactly in the middle on my drawing on my blue line. Okay, there will be R here and R here, normal contact in both edges, and approximately both R's, they are equal because they are equal distance from each other. Here, explain why the book will not remain on the shelf after distance x equal what? All of L over 2, half the length. Okay, look here. When the book is moved now to make the distance half the length of it, that means the book is somewhere here, like this. Okay, forget my drawing is not that accurate. Okay, something like this here. That means the weight is exactly above this point. Okay, so the weight acts downward. It's equal and cancel the weight. So that's why we put it in this situation. Okay, but after we shift it a little bit to the right, okay, now we shift it a little bit to the right. Now the weight acts outside the base area here. So it causes a moment, what? Clockwise, more, and there is no other forces in the other direction. okay, anti-clockwise above the pivot, the point of rotation. I will assume that the point that it's the end of the shelf here, it's the pivot, okay? So this pivot, this moment, make it what? Make it falls down. So what we're going to say here, we're going to say that the center of mass will be out of the shelf, okay, and causes what? A moment out of moment clockwise out of the shelf, okay? The center of mass of the book will be out of the shelf and its line of action, no, the drawing that I just draw, it's for the explanation, no, okay, its line of action makes which is out, oh, okay, which is not on the shelf, which is not on the shelf, makes a moment clockwise, and it is not stable. Why it's not stable? Okay, I'll write it down. No anti-clockwise moment. Balance it. Okay, no anti-clockwise moment. Balance it. Good. Yes, the moment clockwise is there is moment clockwise. There is no moment anti-clockwise. Oh, the moment of the weight of the total weight out of the shelf is greater than the moment of the book inside the shelf. Write this down. Okay. Let's move on to question 14. Here there's a new idea. Okay, they give us a small information about this new idea, and they suppose from us as students to know how to answer this question during the exam. When a concrete is placed under water stress, cracks may form. Scientists are investigating ways to prevent cracks from spreading through the concrete. One way to do this is by adding a very small capsules containing glue to the concrete mix. Okay, as a crack spreads through the concrete, okay, some capsules break, release the glue, which fill the crack as shown. Okay, so there is a crack here. The crack reached this capsule. This capsule, the glue inside it get out from it and fill the crack to make it hold to each other. So what they said, two samples of concrete, okay, are of identical size, are under stress, okay, under compression. Tamam. Sample of consisted of concrete only. Sample A consists of concrete only. Sample B consists of concrete with the capsules with the glue, okay, containing the glue. So the dashed line is the concrete only, and with one that has glue, okay, is the line B, the solid line. Okay, this is the stress-strain graph, as you can see, until it reach fracture as shown. Okay, now what do they ask here? Explain how adding capsules containing glue change the properties of concrete. Now, what do you have to say? Give me from the graph the differences, okay, of the properties between sample A and sample B. Don't give me a huge answer, but only ideas. Initially, both sample, okay, of the gradient, okay. However, stress increase the sample B and sample A. اوكي شكرا يا حمزة. حمزة بعت لنا جواب كثير كبير وفي كثير ideas حلوة صح. اوكي sample A will be more brittle than B. شكرا لك. But okay but with the glue it becomes not brittle. Yes exactly. Sample will be tougher. Okay شكرا يا حمزة. Okay what else؟ نشوف كمان في ناس كتبوا أجوبة. اوكي انا بدي الكل يحاول يجاوب. اها شكرا يا عبد اللطيف. هاي كمان ايديا. B is able to plastically deformed. تمام. طيب شو يعني plastically deformed؟ خلينا نحكي هيك يعني عشان نقدر ناخذ علامات اكثر. شكرا يا نور. sample B can handle more stress than sample B after a certain point. After a certain point. Yes. Okay. طيب, let's check the mark scheme, then we are going to write the answer together. Okay, what they said in the mark scheme. I'm sorry. Look here. I'm talking about question 14. As usual, they give us key points of how they put the marks, the 6 marks. Okay, then these are the mark scheme points. What they said here. Okay, change in properties at what? Low stress and strain. There is no change in properties. Okay, or the changes after a certain point. Okay, energy absorbed by the capsule concrete can be greater. Okay, then why? How do you know that? Because the area under the graph of it's greater, has greater area. Okay, تمام. شكرا يا عبد اللطيف. صحيح. اها يا عيني عليك. Okay, at greater strength capsule concrete is stiffer. Okay, but for greater stress capsules concrete has greater Young modulus. So exactly. Okay, graphs is steeper for capsules concrete. That means higher stress. Okay, the ratio of stress and strain is greater at maximum value or after certain point. Maximum stress over stress or force. Okay, greater for capsules than what? Than that means capsule concrete is what? Is stronger. So what we are going to say here, how we are going to answer this question, to put all these ideas together. Initially, مش عارف ليه طلعت كلمة initially. Okay, initially there is no change in the properties. Okay, but after a certain point, concrete with capsules becomes stiffer. Since it has greater area, greater gradient and greater Young modulus. And also it can absorb more energy since the area under the graph is greater. The area under the graph is greater. Is greater. So it is tougher. What else? And the maximum stress can be reached by it is higher, so it is stronger. So it is stronger. تمام? We need to what's the changes of the properties of the concrete by adding capsules. That's what we did. شكرا يا حمزة ويا نور ويا عبد الفتاح for sending answers. يعطيكم العافية. Next. What they ask here. Question 15. A ball falls through a vertical height of 0.6 meter before bouncing at point A on the ramp here. Okay, there is a ramp and it hits, okay, as shown. Show that the velocity of the ball immediately before bounce is about how much? 3 meters. Now we can answer it by two different ways. We can say so that or kinetic energy with potential energy. It depends on you. So what do we have here? Okay, yes, shukran ya Hamza. Yes, we can use so that. So the distance is 0.6 and u is 0. They ask about v and the acceleration is 9.81 since it's fall by vertical, by gravity acceleration. So v square equal u square plus 2as. So that means v equal square root of 2 times 9.81 multiplied by 0.6. And by using calculator, the answer, it will be 3.4 meters per second. شكرا شكرا. يسلموا ايديك يا شباب بعتوا لي اجوبه بوركتم. You can write it 2 or 3 significant figures, no problem. If you write it like this or like this. Okay. Now it hits, it falls with this speed and bounce. What they said here? Kinetic energy is conserved as the ball bounces off the ramp. The ball becomes at bounces at an angle of what? 70 degrees from the vertical. From the vertical 70 degrees. You have to be careful. From the horizontal 20 degrees. You can use 20 degrees or you can keep using 70 degrees. It depends on how you are thinking. Okay. So they say that the kinetic energy is conserved, and that's why they give us this value, because we are going to answer it here now. That means the speed of bouncing, it's 3 meters per second with an angle 70 degrees to the vertical. Okay. State expressions for the horizontal and the vertical component of the ball immediately after collision. What are the horizontal and the vertical components? Now we know that as it bounces like this with an angle of 70, so that means we have two answers here, two velocities, one horizontal and one vertical. This is the horizontal and this is the vertical. So this velocity, it will be what? 3.4, what we answer here, or 3.43, and what you can write yes, exactly. شكرا يا شباب. Sine is 70, and here 3.4 what? Cosine what is 70. That's the expression that they ask about it. Or you can give us an answer. How much is the answer for each one? How much is the answer? Okay, that's expression. طيب. أول واحد قد إيه بيطلع يا شباب؟ 3.19 and the second one قد إيه بيطلع؟ Okay, 1.16 because we are going to use these values now in projectile motion. So this is the horizontal speed of the projection, and this is the vertical speed of the projection from the ramp as it bounces off at an angle of what? 70 degrees. Memorize these values, we are going to use them, okay? Meters per second, meters per second. Of course, I will not cross this line in the exam. طيب, what they ask. Point A is at 0.86 meter, okay, vertically above the ground, and 1.23 meter horizontally distance from the end of the ramp as shown here, okay? Deduce whether the ball will bounce a second time on the ramp. Does it bounce here into the ramp or outside the ramp? So that means we are going to compare its speed with what? With the horizontally with this distance. So I need to find out what? The time. Exactly. شكرا يا حمزة. So I need to find the time of falling. So what do I'm going to do this answer in both ways, vertically, horizontally. Now, vertically, the initial speed in the vertical axis is how much? We said 1.16. That's u, 1.16. Okay, and we are going to use, okay, so that the distance here, it's negative. Why negative? Because falling down and bouncing is going up. Negative 0.86. Okay, and v, I don't know. The acceleration is negative because falling down 9.81, and the time I don't have it. I need to compare the distance horizontally, the range fall horizontally with this range. That means the range in the x-axis horizontally equal the speed in the x-axis multiplied by the time. And the speed in the x-axis here, it's how much? 3.19, okay, multiplied by the time. So which is equal 3.19 multiplied by the time. So I can do this here. I need to find the time by the y-axis since I have three given here, the u and the s and the a there. To find what? To find the time. So which formula I'm going to use? I'm going to use s equal exactly شكرا ut شكرا الشباب اللي عم بتجاوب معنا الله يعطيكم العافية ut plus half at what squared. So the s, which is negative 0.86 equal 1.16 multiplied by t, negative because there is the negative 9.81, half times 9.81 t squared. And as you can see here, I have two t's, so I have the quadratic equation. I have to fix it. So I'll move this to the other side. It will be 4.905 t squared minus 1.116, okay, 1.16 t minus 0.86. All of this is equal to 0, and I will use the equation we know that in this equation, quadratic equation, I will use t equal a negative b plus minus square root of b square minus 4ac divided by 2. Yes, bravo. And in this situation, I have two different answers. What are these two different answers? If you have a calculator, you can give me the answer. لو سمحتوا. Yes. Are you sure? Okay, 0.55 seconds. شكرا يا حمزة. So I will substitute this time here, 0.50 and 3 times 0.55, 3.19 times 0.55. It will be how much? Yes, how much is the answer here? It will be 1.75 meter. So we will compare this value to this distance. which is greater than 1.23 meter. So it bounces out of what? Out of the ramp. It bounces out of the ramp, or you can say it doesn't bounce again on the ramp. Tamam? So we have here 4 marks. I think here there's 2 marks here. This is step number 1, step number 2, step number 3, and step number 4 to compare your answer with the real answer. That's one way to answer the question, or you can do it. You can find how much the horizontal distance, how long the time here, and compare it with this time. You can do that. Yeah, you can do it in both ways. It depends on the way of your understanding in the exam. Tamam. Any question? So again, here, what we find, we know that it will bounce. We don't know if it bounces here or it will bounces there. So we need to find the range, this range, okay? And this range is equals horizontal speed times time. So the horizontal speed that we just find it out before, 3.19, we multiply by the time. So I will find the time by using the SOVAT, the vertical component of the motion. Okay, and that this time I'll substitute here to find that the distance, horizontal range, is greater than our answer. Any question? Right, let's move on. Question 16. Popcorn kernels contains water, okay? When heated, the water turns into steam, okay? The kernels pops, okay, and move upwards. So this is the initial position of it, and it's jump to reach this position, and they give us, this is a scale diagram, so I need to draw, okay, from the bottom to know how much is the height. You have to use your own ruler and compare it with this distance into the scale, and you do cross multiplication to find how much is the height if they ask about the height. Now let's see, what do they ask us? Maybe they ask about kinetic energy, potential energy, because they give us a scale. The photograph shows how the popcorn just before popping and its maximum height. The time between the two pictures is 83 milliseconds. That means times 10 to the power of -3 to be in what? In seconds. Determine the maximum height after popping. Now we have to know how much is the maximum height. I want from you to use your ruler, okay, to tell me how much the distance that you measured here. Determine the maximum height. Can we use, okay, yes. So distance equal, okay, UT, do I have U? No. Type. So what do I have here? I will not use UT plus half AT squared. I can use because V here is final speed. So what I will do here? What's the information that I have it? So that, what are the information that I have? I have the time. I have that it's the acceleration -9.81. The time it's 83 times 10 to the power of -3. Yes, I will use the equation VT, not exactly. The final speed as it reaches the maximum height is 0. I don't have the initial speed, and I want to know what the maximum height. So the formula, the equation that I will use it, S equal what? Okay, that's equal, but they didn't ask about that. They didn't ask about this in this situation here, but okay, you can measure it by ruler and compare it with the graph here. So S equal what? VT minus half AT squared. So the maximum height equal 0, negative, so half times 9.81 multiplied by 83 times 10 to the power of -3, all what? All squared. By using the calculator, our answer is 3.4 what? Centimeters, because the answer here is 0.034 meters. Shukran ya Hamza for answering. So the scale here, it's in each centimeter, and we have to take pictures, okay, measured by ruler. Now what they ask here, calculate the initial speed of it as it pops. Now we have to know that initial speed, okay, yes, you can use the formula. Yes, you can use so that, okay, or you can use what? Kinetic energy final equal potential energy initial. Kinetic energy initial equal gravitational potential energy final. You can use any one of them. So half mu square equal mgh. M with m cancel out each other. So u equal square root of 2gh and square root of 2 times 9.81 multiplied by the height that I just find it out, which is 0.034, and by using the equation here, I will get that the answer it's 0.82 meters per second. That's the initial speed as it gets out. You can use solve that also. We can use this equation to find the answer. It depends on you. تمام. Okay. Next, what do they ask? The average water content in the popcorn, okay, is 14%, 0.14 of the total mass of it, okay. As it heated up and pop, the steam ejected downwards, okay, and the pop will move upwards with the initial speed of how much? 1.5 meters per second, not 0.82, 1.5. Calculate the speed of the steam as it ejected. The total mass of it is this amount. Now, how we can answer this question? How we can answer this question? Now, because both of them was at rest, and then the gases come out downwards and the popcorn goes upwards. So, which formula I'm going to use? Yes, شكرا يا حمزة. حمزة دائما ما شاء الله بيبعت لنا الأجوبة أول بأول. We have to use that the total momentum before, the total momentum initially equal the total momentum after. The momentum of the gases final plus the momentum of the popcorn final. And everything is equal to how much? To 0 here. So what do we have here? M, U, and V. That the mass for the popcorn and the mass for the gases, okay? So since the mass of the gas is 0.14 from the mass of the total mass here, which is 0.11 grams, now that means, shall I keep it in grams? Yes, you can keep it in grams. So we said that 0.11 multiplied by 0.14 to find how much is the mass for the gases, okay? And the mass of the gases is how much? It will be 0.0154. Yes, shukran, grams. Okay, so the total mass for both of them, it was 0.11, and that means that they will divide the masses. So how much mass left? So here the mass of the gas is 0.0154, and here what's left, which is 0.0946 exactly. Both of them have the initial speed of 0. Now the initial speed for the popcorn is what we just find out, 0. No, they give it to us, sorry, 1.5. 1.5. Okay, how much is V for the gases? So we said that the initial momentum before equals 0, so that means equal the momentum after for the gas, mass of the gas multiplied by the velocity for the gas plus mass of the popcorn multiplied by the velocity of it. So let's move this to the other side. It will be negative because negative is downwards. So that means 0.0946 multiplied by 1.5 is equal to negative. How much? Oh, you can put this negative. It's equal to 0.0154 multiplied by V divided by V equal negative 9.21 meters per second. And this is the average gas ejection. Negative, that means downwards, 9.21 meters per second. شكرا للشباب اللي عم بيجاوبونا بعتوا لنا مسجات. This is how we are going to find the mass of the gas. Okay, and the total mass for both of them is 0.11. I subtract to know how much is the mass of what? Of the popcorn as it gets out. Popcorn. Yes. Next, another experiment about what? A sliding object. What they ask in this question, question 17. Glider with a cord connected to it. So they are talking about maybe young modulus, maybe energy stored. Let's see. An elastic cord was fixed between the ends of an air track and a glider like this. The glider has pulled to the right, given the elastic cord to extension of delta x as shown here. Okay, so this is the original length from here to here. These are light gates, okay, and how much the cord will extend delta x. Whenever we put it more, we release it, it go further faster through the light gate, and we have a faster speed. What this is, the glider was released and moved to the left as light gate passes. As the glider passed the light gate, okay, they measure the maximum velocity of the glider. We know how to measure it. We need to know how far is these two distance, okay, from each other. This distance divided by the time that it passes the light gate, it's what? It's the maximum speed or maximum average speed. Student obtained the following results. As you can see, it's approximately straight line passing through the origin. Okay, what they ask. Part A of the question, the principle of conservation of energy, okay, predict that the graphs should be a straight line through the origin. For the range of values delta x used, the elastic cord obeys what? Hooke's law. Explain this prediction. Why they have to be a straight line? Yes, who can tell me? Yes, the energy stored is kinetic, and the energy stored inside its elastic potential energy, it's converted to what? Kinetic energy. So we have to put both of them to make relationship. زي ما مرات كان بيسألني صباح, I think. Okay, kinetic energy final is equal what? Elastic potential energy what? Initial. So half mv square equal what? Half force multiplied by what? Extension. Right so far? طيب بلاش هاي الفورمولا معناته half k لأنه ال k obeys Hooke's law, that means k is constant x square. هيك تمام؟ بصير أكتبها زي هيك؟ طيب ماشي. So let's continue. Half with half cancel out each other. Can we make it as a subject of the formula? Look, what is the subject of the formula? V in the y-axis, and what here the extension is x. Can I make it linear equation? Let's see. Okay, v square equal k over m x square, square root, so v equals square root of k over m what? X, which is y equal mx plus c. So yes, it is what? It is a correct prediction. Correct prediction. Since it is what? Since it is linear. Since exactly. Since they are directly proportional. They are directly proportional. Directly proportional. Any question here? Is it clear? الأمور تمام واضحة. أكيد. طيب, let's move on. Double I. Determine the stiffness K of the elastic cord. Determine the stiffness K of the elastic cord. The mass, okay, of the glider is 300 grams. That means 0.3. Why they give us like this? Why they want to find K? Look, the K here is the gradient. The K here, it's divided by M, is the gradient. So I have to find what? the gradient of this specific line if they say that it starts from 0. So I have to pick 2 points here and find what the gradient, and I will calculate it. So let's pick this point here because it's not the cross, because I'm talking about the line. It's fixed point here with these 2 coordination. So it will be 0.5 with 4.2, 4.4, sorry. And let's see the origin, okay, 0 with 0, okay. So what we are going to say here, we're going to use the gradient, and as we say that gradient equal change of the velocity divided by change in the x-axis in the extension. So the points are 0.5 in the bottom here, 0.5 and minus 0 divided by 4.4 minus 0, and by using these 2 points, how much is the gradient here? It will be 8.8. Okay, now this is the gradient. Okay, it's equal to what? Square root of k divided by what? M. And I need to find k. So square. So 8.8 square equal k divided by the mass, which is 0.3. Do cross multiplication. How much is the answer? K equal 0.3 multiplied by 8.8 square. If you have a calculator, you can give me the answer. How much is the answer? 0.3 times 8.8 square. ده بيطلع الجواب لو سمحتوا 23.2. okay, which is, we know it's a Newton per watt meter. Okay, any question? So you have, there's range of the accepted answer. It depends on the points that you take to find the gradient. Okay, maybe you can take this point with this point, this point with this point, any other 2 points, and you can find the gradient of the biscuit line. Okay, any question here? Allah يعطيك العافية. Let's move on. When the glider was removed, okay, to the right, more than 0.5 meter, the graph began to curve. Okay, explain why the shape of the graph changes. Why? Who can tell me why the graph is not straight line now anymore? That means it exceeds what? Exactly, because it exceeds the limit of proportionality. So is it directly proportional anymore? Is that the extension and the directly proportional to the force? No, it's not directly proportional. It exceeds the, yes, شكرا يا نور, شكرا يا حمزة, شكرا يا عبد الفتاح, the limit of proportionality and the spring, okay, or لا مش spring, the rubber band, or the graph, okay, the graph will not make the extension and the force are directly proportional. That means Hooke's law is not obeyed anymore. Any question? Okay, let's move on to question 18. Here in this question, what they ask: a student carries out an experiment to determine the Young modulus of copper. She added a mass M to the free end of a sample of a copper in a form of a long thin wire, okay, and the corresponding extensions delta x are what? Measured. This was repeated for different masses, increasing what masses. State the meaning of the term Young modulus. What's the meaning of Young modulus? Yes, the ratio of stress over the strain, shukran, over the strain for a material. Any material has a certain Young modulus, which depends on the stress over the strain of it. Part B. The student repeated the measurements of the diameter of the wire, okay, at different positions and orientation. Okay, she obtained the following results. As you can see, these are the following results. Determine the cross-section area of the wire used. How much is the cross-section area? What I can do to find the cross-section area? As you can see here, we have three significant figures. We find the diameter, the average of the diameter. Okay, the average of the diameter. So 0.230 times plus 0.235 plus, okay, 0.23 plus 0.24, okay, divided by 4. Then I will find what, which is equal 0.234 meters, millimeters. Then I will say the radius is the diameter divided by 2, which is 0.234 over 2, okay, 0.117 millimeter, okay. Then they ask about what the cross-section area. So the area equal pi radius square, so which is equal pi multiplied by 0.117 times 10 to the power of negative 3 to convert it from millimeter to meter, all squared, okay. And by doing that, I will get the answer of how much 4.30 times 10 to the power of negative 8 meter watt square. Now, since they give us all the values in three significant figures, I can put three significant figures. Yes. Yes, it's better. Shukran. Correct. So far, there is no problem in this question. Now, what they ask here, double I. The student plotted a graph of M against delta X. She measured the gradient, obtained a value of how much? 195 kilogram per meter. Determine the Young modulus of the copper. The length of the copper is this value. Now, what we have to do? We know that Young modulus equals stress over strain, which is FL over what? EA or XA. Now, the force here is the mass multiplied by gravity acceleration multiplied by the original length divided by what? Delta X, okay, multiplied by what? The area. Now, what we just find, what they give us here, the value here is this value, mass divided by delta X. And the area, we just find it from the previous part I, and they give us the original length here, okay, L. So we substitute the values, okay, so which is equal 195, okay, multiplied by 9.81, multiplied by the length, which is 3.5 meter, divided by the cross-section area, which is 4.3 times 10 to the power of negative 8. We just find it out before. And the whole answer by using calculator, if you have a calculator, give me the answer. It will be approximately 1.56 times 10 to the power of 11 watt Pascal. 1.6 times 10 to the power of 11 Pascal. You can write it 2 or 3 significant figures. Yes. Is it 5.5? I have two different answers. Is it 5.5 or 5.6? 1.55 or 5.6? If you please check and tell me the answer, okay? طيب. the experiment was repeated by another student using a 2 meter length, okay, wire, not 3.5, 2 meters, okay. Suggest how the values obtained by the gradient, okay, number one, and hence the young modulus will differ between the students or not will be different. Now, because we have shorter wire, not 3.5 wire, it says shorter wire, that means, okay, exactly, shorter wire, that means the extension will be what? Smaller, so the gradient will be what? Greater. That's number one. Number two, what about the young modulus? Of course, it remains the same. Shukran لكم. Yes, exactly. So, shorter wire makes the extension delta x smaller. So, the gradient here will be greater, but the young modulus remains the same. The young modulus remains the same. Exactly, exactly, Ashabab. Yes, let's move on to next question, question number 19. In this question, what is it? A student uses the apparatus shown, okay, to investigate the forces acting on a uniform solid sphere placed in wire. There is a thread, and you can see a balance. There is water, and the sphere is connected by the thread by a holder. They want to measure how much the reading on the balance here. Draw the free body force diagram for the sphere, okay, in which suspended by here in the water. What are the forces act on it? Yes. Who can tell me what are the forces? Yes, شكرا يا حمزة. مين كمان بيقدر يبعت لي شو الفورسز الموجودة هون? What do we have? Okay, upthrust and weight. Exactly. يا عيني عليك. شكرا شكرا. So we have weight here, it's downwards, and you have to write weight, not W. And we have two forces that acts here, which is what? Upthrust plus what? Tension. Exactly. Upthrust plus what? Tension. Good. Excellent. Next, what they ask. As the sphere was lowered into the water, the reading on the balance increased from 315 to 465 grams. Okay, so when we take it off, it becomes 0.315, and we put it in, it will be 465 grams. Okay, what they ask here, what's the reason of this change? Explain the increase of the reading by the on the balance. Your answer should include reference to Newton what? Third law. Yes, who can tell me Newton's third law between what and what? What are the forces that are equal and opposite in direction? Yes, شكرا يا حمزة. مين كمان? Not necessarily to write water molecules, okay? تمام. شكرا. أيوة برافو هيك. يسلموا. Okay, as the water is pushing the sphere upward by the upthrust force, upthrust force, the sphere pushes the water downward by an equal and opposite force, and this extra force on the water is the reason for increasing the reading, is the reason for the increase in the reading. ما شاء الله عليكم، رائعين رائعين رائعين. ملاحظين هذا الامتحان صار فيه الحكي أكثر من الكالكوليشنز، مش زي الامتحانات اللي حليناها المرة الماضية، صح؟ طيب نشوف هلا اللي بعده بيحكي لنا diameter of the mass determine the mass of the sphere. Determine the mass of the sphere. They give us the density of the water and the density of what? Of the sphere. They ask about what? Determine the mass of the what? Of the sphere. How do we know? How we can find out the answer? Yes, who can tell me? Yes. Bravo. The upthrust is equal to what? To the weight of the displaced what? Displaced water. I mean by this is equal to the force caused by what? Caused by the increase of the reading, صح? Caused by the increase of the reading. The increase of the reading. طيب. So that means, which is the upthrust equal, how much is the change in the reading? It's 150 grams, صح? So that means the mass of the water displaced. Yes, give me values لو سمحتوا. Okay, so 0.465 minus 0.315, it's equal to how much? 0.150 what grams. Okay, now, okay, that means what? I have to multiply it by G. Yes, all this I have to multiply it by what? By G. So by multiply it by 9.8, it's kilograms, sorry, not grams. Okay, multiply by 9.81, I will find how much is the value of the what? Of the force, right? And by finding the value of the force, okay, now exactly 1.47, okay, Newton. Now what we have to know here, we know that density times gravity times volume is equal to what? To the upthrust. أنا أخذت كثير كتابة هون، خليني أمسح والله هذا الحكي وإيش وأكتب من أول وجديد. I'm sorry. عشان يوسع الجواب مرة ثانية. Equal weight of displaced fluid, which is equal to 0.15 multiplied by 9.81, which is equal to 1.47 in Newton. طيب هذا شو equal? هذا equal density of the fluid multiplied by G multiplied by volume displaced. Okay, all of this I want to find how much is the volume. So by doing that, the volume displaced is equal 1.47 over the density of the fluid, which is 1000 multiplied by 9.81. okay, and the answer will be 1.5 times 10 to the power of negative 4 cubic meter. Then, okay, then I would say that we know that step number 1, step number 2, step number 3, we know that density of the sphere equal mass divided by the volume. By doing cross multiplication, the mass of the sphere equal the density, which is 2000 multiplied by 1.5 times 10 to the power of negative 4, and the answer will be 0.30 كيلوغرام. شكرا للشباب والصبايا اللي عم ببعثوا لي الأجوبة. شكرا عبد الفتاح، شكرا يا حمزة، شكرا كمان رباح I think بعت لي. ف 0.30 watt kilogram. The last part of this question, this exam, what they said. Triple I. The water was replaced with the same mass of oil and the experiment is repeated, okay? The density of oil is less than the density of the water. Explain what happens to the final reading of the balance. Does it increase to the same value or above or below, and why? Okay, don't forget the density of the oil is less. طلعوا هون على الأرقام اللي احنا طلعناها هون. The density, okay, the density of the fluid count 1000. Okay, if we are talking about the same mass and we reverse the thing from being water to being oil, شو بصير بالupthrust؟ أيوة, since we are talking about the same sphere, the same volume, so the upthrust will be less. And since the upthrust will be less, that means the force downwards will be less, and due to Newton's third law, okay, that means the downward force will be less, and that means the reading balance will increase to a lower value than the initial value. Okay, due to our best, since the sphere has the same volume, so the upthrust decreases, making the downward force decreases. So the reading, okay, increased by a lower value. It will not increase to how much they said, to 465, maybe 445, maybe 430. We don't know. The weight of displaced fluid is decreased. The weight of displaced fluid, now it's oil, is decreased. Yes. Any question here? Any question? طيب. Let's move back to the teacher. Why some people got you, and I don't know. I don't know. Ask them. Okay, let's move to the multiple choice questions. Okay, can I return back to question 17 I and double I? Okay, can we return back to the end? Okay, because I'm recording it. Okay, in the end I will turn back. ماشي. طيب, let's move on to the multiple choice questions. Okay, first question, what they ask. Yeah, I want from you to give me the answers لو سمحتوا. Yeah, which one of the following quantities has the SI base unit, okay, of kilogram per meter square per second cube? The answer is Yes, is the power. Is the what? The power, because momentum is kilogram dot meter per second. The force is kilogram dot meter per second square, and work is kilogram dot meter square per second square. Divided by time, it will be the power. Yes, shukran. صح. So the first one, C. Second one, yeah. Which one of the following statement describe the gravitational field strength acting on the body at a point? Gravitational field strength is the gravitational force per unit length or mass. Yes, it's mass. Exactly. شكرا يا نور. شكرا يا عبد الفتاح. شكرا يا حمزة. Yes. شكرا. Yes. طيب نيجي نكمل. It's not energy, of course. Question 3. The diagram, okay, below shows the velocity of an object before and after a force applied. That was it, moving in this direction and change the direction to be upright. Okay, the magnitude of the velocity did not change. Okay, there is no change in the velocity. Hey, it's a very unique word. Okay, which one? Okay, which one of the following represent the direction of the change in velocity? Yes, change in velocity. Bravo. So the change in velocity, not the force, the change in velocity. Now, I told you, this is the original velocity. It was like this. This is the what? This is the other velocity. It's like this. It doesn't change. So the resultant of the change in velocity, it's from here to here. This is our change in velocity. So the answer is what? Is B. Okay. شكرا عبد الفتاح. شكرا حمزة. شكرا يا نور. If they ask about the force, it will be in this direction. If they ask about the force that acts, it will be perpendicular. Okay? طيب نكمل. Next, what they ask. A ball of mass, okay, M projected vertically upwards, the air resistance friction force is F, acting on the ball in all times. Which of the following equation would apply to the ball as it travel upwards? So it's moving upwards. It's moving where? Upwards. So what are the forces acting on it? There's weight, and also there is what? Friction force. So the weight and the friction force, they act where? In the opposite direction. So, and since it moves upward and it's still in the air, that means there's acceleration, and the acceleration is where? Downwards, which is the acceleration of free fall. Exactly. So the answer is, the answer is D. The answer is D. Okay, mg, the weight, plus the friction force equal ma, not minus, and not equal 0. This is the correct answer. Both forces act in the same direction. They stayed upward. So the friction force of the air resistance downwards. Number 5. Two objects P and Q are at the same what position at time t equals 0. The graph shows how the velocity v varies with the time t for each object. Okay, that's for object P. It was constant speed, then suddenly changed the speed to be in opposite direction. Okay, and this one, the speed increases, but with decreasing acceleration. Okay, sorry, decreasing acceleration. Yes. Which one of the following statement describe the positions of P and Q at what? 4 seconds. As you can see, this area and this area, what they are equal. So it was moving forward, then what? Return backward and return back to original position. Okay, but this one keep moving where? Object Q, it keep moving what? Forwards, like this. I don't know how far it is, but I have to find the area under the graph. Yes, so the answer is what? Most of you give me the answer is D. خلينا نشوف. D. Q is farther from the initial position of P, of course. P is farther, no. Okay, P and Q have the same distance, no. Okay, same position, so the answer is what? Why do they don't have the same distance? Now, this distance covered forward, and this distance backward is the whole distance like this without the curve here. So they don't have the same distance. So the answer is D. Question number 6. What they ask. A ball is traveling, okay, with a horizontal speed of 7 meters per second. The ball hits a vertical wall and bounces with a speed of 5. That means it's -5. This is v. Okay, the ball has an acceleration of this value while it's in contact with the wall. Which of the following expression gives the time between the bouncing? Okay, so we know that acceleration equal v minus u divided by t. So that means t equal v minus u divided by a. So it will be -5, -7 divided by without negative 300. So the answer is what? The answer is why it's negative? Exactly, why it's negative? Because it was moving to the right and the bounce or the force is in the opposite direction, and that's why the acceleration is in the negative. So, and the time cannot be negative here, ya shabab. Here the time is negative. Can the time be negative? No, the time cannot be negative. So the correct answer is what? Is A. Tamam? The correct answer is A. Let's move on. To release x and y of masses m and 3m respectively travel with the same what speed. Okay, I don't have I don't واحد بيسألني من الشباب can I use change in momentum? I don't have enough information to answer the question, but yes, I can use force times time equal impulse. Yes, change in momentum. A trolley x and y have masses of m and 3m. They are moving with the same speed towards each other. Which of the following statement is correct? Now, okay, they collide and move off together as they collide. So that means what we are going to say. We are going to say about x, y, m, u, and v. They have same v. Okay, this is the m here and here 3m. Here they have the same speed v and v. Okay, so let's do the equation. Mu plus mu equal m plus m multiplied by v. Here for x, here for y, here for both of them x and y. So m multiplied by v minus, because in opposite direction, 3m multiplied by v. So it's negative 2mv is equal to m plus 3m multiplied by v for both of them. This is final speed. Let's write u here. So, okay, we will not get confused. This is u. This is u. Okay. Or you can write it v and this write x. Okay. So here it's 4mx. So divide by 4m, divide by 4m, x equal v or u divided by 2. Okay. The forces on x and y during collision, it's greater. No, they are equal. So this is wrong. This is wrong. Okay. The speed of x after the collision is greater. The speed of x is less than. So the speed of both of them, it's less, not greater. Look, it's v divided by 2. It's half v divided by 2. Okay, it's half v or negative v divided by 2. So the answer is D. So the speed was u, and for the speed of both of them, it becomes u or v divided by 2. This is question what? This is question number 7. Okay. Question number 8, what they ask. A motor is 68% efficient, used to raise a load of what? Of 350 Newton of a height of 25. Which of the following gives the expression of the energy supplied? That means the energy input. Now we know that efficiency equal energy out, what's happened, divided by what? Energy N. They ask about the energy N, so energy N is equal to the energy out, which is force times distance, or the mgh. So it's 350 multiplied by 25 divided by how much? Divided by what? 0. What? 68%, or multiply by 100%. You can remove this one. So the answer is what? No, it's 0.60. Yes. So the answer is D. Yes. Shukran, shukran ya shabab. Be careful. You have to put the percent here. You have to put percent. Yes. Times 100%. What do I mean by 100%? 100 divided by 100. So it's 1. Okay. Shukran, shukran. Next, number 9, what they ask. It's a very easy question. Okay. We have a length a steel wire that fixed at one end and increased force applied to the other end. The force extension graph of the wire as shown. Which row of the table identify the points P, X, and Q? Now we know that P, it cannot be, it can be yield points, yes. And a Q, it can be elastic limit. And yes, shukran. And this is limit of proportionality. So the answer is C. Yes, shukran ya Noor, shukran ya Hamza, shukran ya Abdul Fattah, shukran ya Shabab اللي عم بيجاوبوا. Yes, thank you. Last question for this paper, what they ask. Some students were shown a velocity time graph for the motion of the falling object through a liquid. As you can see, it's there is acceleration. The acceleration decreases. Students suggest a possible explanation for the decrease of the gradient. Which explanation would be the reason of this? What? Okay, the drag force increases. Yes, this is the correct one. The gravitational force increases. No, the weight doesn't change. The temperature, when the temperature changes. Okay, the upthrust changes. No, so the answer is A, and that's it for this year. الله يعطيكم العافية. نرجع للأسئلة.